Hello, Year 10. We're back with question 2, differentiating polynomials. In this second question, we are going to find the gradient of the curves at a specific point. Okay, so we're going to need to use the gradient function, take the derivative or differentiate the function, and then sub in our x value to find the actual gradient at that point on the curve. So I'm going to do two examples. The first one is y equals 2x squared minus 3x. So we're going to take the derivative. I showed you how to do that in the previous video, so here it is, dy dx equals 4x minus 3. This function gives us the gradient at any point on the actual curve. This is the gradient function. So, at the point x equals 3, we simply sub in the x value and generate the gradient. 4 times 3 is 12 minus 3 becomes, you guessed it, 9. Okay? Let's have a look at what this means from a visual standpoint. I've drawn two curves. I've drawn our curve, y equals 2x squared minus 3. There it is in red. And I've also drawn the tangent to the curve at x equals 3. This line, y equals 9x minus 18, is the tangent to the curve at x equals 3. As you can see, the gradient of this line is 9. The coefficient of x. It's the number in front of x. And there it is. Here's the second one. The second one asks us to find the coordinates of the point on the curves where the gradient is 0. So it's asking us, where on this curve is the gradient 0? At what coordinate? Let's click to see how we finished this one. Here's our function, y equals 16x plus 1 over x. Again, we have to take the derivative. We can't do it like this though. We must move this x into the numerator like our previous video. To do that, we use the rules of indices. Our gradient function becomes well, this is actually our function. This is not our gradient function, is it? I've made a mistake here. Let's put that as y. This is our function still. Now we can take the derivative. Now we can differentiate as normal. Our function becomes 16 minus x to the power of negative 2, because we multiply by negative 1. That's where that negative comes from. And then we take away 1 from the exponent. Minus 1 is minus 2. Now, let's simplify. We must simplify. Okay. Let's bring our exponent back into the denominator. And it becomes 16 minus 1 over x squared. The question doesn't stop here. The question asks us, for what value of x will the gradient be 0? So in other words, when will dy dx, the gradient function, equal 0? Now we have to replace dy dx with 16 minus 1 over x squared. From here we have to solve for x. Let's get everything positive. Let's move this term to the other side so it becomes 1 over x squared on the other side of the equation. Now we're following Mr. Stevens' golden rule of solving when we have fractions. Always multiply by the denominator. We're going to multiply by the denominator, so it becomes 16x squared equals 1. Remember, we're solving for x now, so we need to divide out the 16. X squared equals 1 over 16. The final step is to now take the square root of both sides, as you've seen many times. However, there's more than one answer. When we take the square root of 1 over 16, it can be plus or minus 1 over 4. So last step, finally, we are asked to find the coordinates of the point. This is only the x-coordinate of the point. Why don't we now find the coordinates of the point? Okay. There's two different coordinates where this is true. The function itself is used to generate the coordinates. We don't use the gradient function. The gradient function generates the gradient. The function generates all the coordinates on the curve. So when we sub in x equals 0.25 and do the math, the y-coordinate is 8. We sub in 0.25 into these x values. And the other one, when we sub in x equals minus 0.25, what are we going to have? 16 multiplied by minus 0.25. That's a quarter of 16, isn't it? That's 4, minus 4. And then minus 1 over 0.25. If we substitute negative 0.25, we're going to have this plus will change to a minus, and we have 1 over a quarter, which is 4. We have minus 4, and minus 8. Those are our two coordinates, where the gradient equals 0. If you graph this function, which I recommend you do, go to desmos.com, graph this function, and find out where does the gradient equal 0. These are the two coordinates where that is true. So I've answered these two questions. Try the other two on your own. See if you can figure those ones out. Pause the video. Okay, let's see what those answers are now. Thank you very much, and see you tomorrow.